Mass spectrometer is what we use to measure the mass of the different atoms or compounds within a sample. So you have the sample going in on one side. It is heated, so it has to be vaporized, so it's a gas. It's then ionized. The electrons are pulled off so that it becomes positive cations. Those positive cations go through a magnetic field and then through this bend, and as it's speeding up through the magnetic field, depending on the mass, depends where on the detector it hits. So we can use the information from the detector to figure out the mass and then the relative amount of those masses. We're going to watch a video that describes how the mass spectrometer works and information about how it hits the detectors. I highly suggest that you continue taking notes that they are showing you in this video. So we can take the information from a mass spec and determine the mass, the relative atomic mass of that element or compound. Relative just means that the answer is going to be unitless. So if we look, the x-axis represents the mass per charge ratio, and then we have the relative abundance off to the side. So the x-axis is the mass, and then the y-axis is the relative abundance. So we can figure out how many of our sample was had each of those masses. So if we look, the mass of 10, there was about 20, and then a mass of 11, we had about 100 atoms. So to figure out the relative atomic mass of boron, we would take the mass, 10, times the number of those atoms with that mass, which is 20, and then do the same thing, mass of 11, and we had about 100 atoms. We're going to add the isotopes together, and so that would give us 1,300. Then we need to divide by the total number of atoms. So 100 plus 20 is 120. So the relative mass then would be 10.83. Again, it's unitless because it's relative. Now I went to 2 decimal places with my answer, and when we talk about masses, we tend to go to 2 decimal places so that it matches how the periodic table gives us the mass of the element. Looking at another example, we have 3 isotopes, neon 20, neon 21, and neon 22. So we would take the mass, 20, times the abundance, 90%, plus mass of 21 is at 0.17%, plus the mass of 22 is at 8.93%. And so if we were to add all of that together, we would have 2000.03. We then need to divide it by the total amount. So if we add 90.73 or 0.17 and then 8.93, we have 99.1. And so then we would divide those 2 values, and our answer would be 20.18. Again, it's unitless because that's what relative means. Make sure you try the problems.